Hi students, Miss Walsh here. So today we're going to do some more probability. We are going to see that sometimes in the question there's more than one distribution. And then we're also going to do the inverse of the normal, which is when we're actually, instead of finding the probability, we're given the probability and we need to find the value of the random variable. All right, so we start off nice and easy, right? This is an X that is normally distributed. Pardon the bad drawing. Art was not my forte. So this is a mean of 34 and a standard deviation of 2. And what we're asked for is we're asked for the probability that the value will be greater than 35. Okay, we know how to do this. Just go to the toolbox. Probability, always cumulative with the normal, right? And then we're going to put in, remember, first the mean, then the standard deviation. And then if you hit 35 right now, remember, it's going to give you the area leading up to it, right? The calculator thinks from left to right. So instead, because we want the upper area, just put in a really big number, okay? And so what we end up with is we end up with that the probability that X is greater or equal, actually forget the equal, even though remember for the normal distribution it does not matter, right? The value of the exact variable is pretty much 0. 309. Okay. So what happens now? Here we're asked if 4 values are chosen, find the probability that 2 are greater than 35. What you have here, your random value was the value. Here, your random variable changes, and what you now have is you have the number of values that fit. So this is binomial, because remember what you're going to do now is you're going to pick a number, and either it's going to be greater or not. So this, the y, is now binomially distributed. Remember, it's always NP. So now instead, you're doing 4 trials, and with that probability, right? So this is tricky. All right, and what we need is we need the probability that it equals to exactly to 2. Hopefully you remember how to do this. Go to the toolbox. This is density, right? Because it's binomial and you want one specific value, okay? So you should just have the binomial. Remember, what did we put first? First n, then the probability, and then the k, which is the number of successes that you would want, yeah? So remember, this is always NPK, so it's going to be binomial NPK. And you want exactly 2 successes, and there you are. Okay, so always watch out for that. You will notice that the number of values that you've picked is also discrete, so it's independent. You're picking a value, and either you succeed or fail, and so this is typical binomial situation. Okay, let's go down to number 3. I'm going to skip number 2. Alrighty, so the length of a trout in the lake normally distributed with a mean of 41. Do draw it. It's just a way to communicate with your brain, to kind of, you know, visual representations do help. All right, and then we've got a standard deviation. Find the probability that a trout quote is less than 34. Again, easy peasy, lemon squeezy. This is clearly normally distributed, right? And so what we're after is we're looking for the probability that it's less than 34. No problemo. Let's go to this, and then probability, and then cumulative, right? Because it's normal. Again, you know, pause it. Do it by yourself. You don't need me. And then comma, what do we want? We want 34, right? Remember, you don't have any upper value because you're interested in the area up to that. All right, so what we have is we have 0.0849. Okay, gut, done. B. George catches 6 trout in the afternoon. Find the probability that at least 2 of the trout are more than 34. State any assumptions you're making. Okay, so here, x, the variable x, so when you had x normally distributed with 41 and 5.1, the actual variable were the lengths of the trout, right? Now your variable changes again, okay? So now your variable is the number of trout that you're going to be catching, okay? So now again, this is going to be binomial, and this is going to be 6. And now be careful, what they want is they want more than, okay? So the first little step that we have to do is we have to just quickly determine the probability that it's more than 34, okay? So we actually want this probability. Remember, the area under the curve is always 1. So we're just going to go 1 minus that. Boop, boop. Alrighty. And what we end up with is we will end up with 0.915. I'm just speeding up a little bit. Okay, so this is what our distribution looks like now. Okay, and so what we want is we want the probability that that variable, which is the number of trouts caught over that length, is greater or equal to 2. Okay. Alrighty, so remember what we're going to go. We're going to go to the binomial, and we're going to go to the cumulative, and then we're going to put our n, our p, and then remember, you're going bigger than 2, 6 altogether, so you're going to go from 2 to 6. Let's do it. Probability, cumulative, binomial, and then so we have 6 trouts. Each time that you're doing this, they're independent, right? You catch a trout and either it satisfies that or not, and you're happy with anything from at least 2. So you're picking 2, 3, 4, 5, 6. Okay. Whoa. This is good. But look at how high your probability is, right? Like you have a 91% chance every time. So if you're doing 6, the probability that you'll get at least 2 should be very, very high. You should totally go fishing there. Except fishing is a bit boring. Okay, so now we're going to go the other way, okay? So the lifetime of a battery is normally distributed with a mean of 40 hours and a standard deviation of 1.4. Of course, we're going to draw this first. Find the probability that a randomly selected battery lasts longer than 42 hours. Whoops. Okay, so we've got a mean of 40. Standard deviation. This is not new. This is still the same thing. 42. Longer than 42. Probability that x is greater than 42. Okay, just super quickly gonna jump here to my normal distribution. So remember mean, standard deviation, and then 42, and then a really big number, right? So we cover all of it. Alrighty, so what we get is we get 0.0766 approximately. Okay. Find the probability that at least 3 batteries from a pack of 5. Okay, so again, hopefully you recognize this. This is now binomial, right? So before that, it was the length. This x here, that was the length of time that the batteries are functioning. Whereas here, your y is now the number of batteries that satisfy that, yeah? So you have a pack of 5. And then again, you want, okay, good, we don't have to do anything with the probabilities here. 0.766. Okay, and what we want is we want at least 3. So again, you know, binomial, pause it, do this, right? Don't just watch me, but try it. Can you get this? Okay, so n, p, and you're happy anywhere from 3 to 4 to 5. Good, so you get 0.00399. Okay, here comes the new part, okay, in C. So now they're saying the lifetime of 97.5 batteries is less than a certain value. Find this value. So this now is your area under the curve, okay? So I'm just going to draw it in green. So I'm just going to redraw it. So 97% does glow somewhere here. And again, your mean is still 40. Your standard deviation is 1.4. Okay, and so now we know this probability, and what we need is we need this variable t. So the way that we do that is we actually going to use the inverse function on our calculator, okay? So what we're going to do is we're going to go to inverse normal. Let's do this. So go to probability and then inverse, we're still in normal. And so now what we're going to put in, still going to put in our actual distribution, so behavior of the variable. And this is 1.4. And now, instead, we're going to put in the area as a decimal. Boop. And what it gives us is 42.5, okay? So again, you always put the mean, standard, and then the probability. Remember, calculator thinks from the bottom up, so it's always less than the probability that you're actually putting in, okay? Alrighty, so then we get, so that our t is equal to 42.7. Does this answer make sense? Yes. Notice that it's quite a bit above the mean, right? So more than a couple of standard deviations away, right? Which makes sense because it covers most of the area. Okay. So this is always your notation for this, okay? You always have to put in the less than. You're always doing this I here tells you that it's the inverse, mean, standard, probability. Okay, let's do question 5. Okay then, alrighty. So now we have this distribution, whoop, whoop, and then our standard is 2, because remember this is the variance, right? And what we need is we need the k so that the probability that it's less than k is 0.2. So it's going to be somewhere here, right? You're only interested in covering 20% of the area. Good, let's do that. So we're going to go to normal I, the inverse, and then all we have to just put in is like 6, 4, and 0.2. I'm just going to cheat. Ha, ha, ha. Okay, so just go to that inverse and then 6. Sorry, not 4. My bad. 2. So 6, nope, okay, try it again, 6, and 2, and 0.2. Okay, then we have 4.31. Again, does this answer make sense? Or why does it make sense? Well, you can see that it's somewhere to the left of the mean, so it should be a number that is on the left side, right? Because it's only covering the 20%. Okay, last one. So what we're asked for here is we're asked for find the probability of k. So this is important, okay? If you're getting tired, too bad. Because here we are given that the probability of bigger than k is 0.3. So now this is what you're going to put in. But remember what I said, okay? The calculator always thinks from the bottom up, alrighty? Which means that what you're actually going to have to do when you put in your normal ICDF is we are not going to put 0.3, but we're going to put 1 minus that 0.7, okay? You can just put 1 minus. Actually, it'll do the subtraction for you, okay? So 1 minus, if you're too lazy to calculate, 0.7, and what you'll end up with is you end up with 7.05, and of course that also makes sense because there it is, it's higher than the mean, and that's what the value is. That covers more than that. Okie dokie. So again, watch out in those longer questions for changing the variable up, going from normal to binomial. The IB loves to do that. And then, of course, practice the normal. Ciao, ciao.